right. Thank you very much for the opportunity. It's super cool to be here. My name is Gergely, and I will present on Spare Course. So we'll focus on how to utilize cloud compute resources in the most cost-efficient way using the open source tools that we have built in the past year or so. Because I haven't presented in this series yet, I thought it would be good to have like a super short intro, and then I will focus on the project updates from the past quarter. Introduction, like why this is even required, or why is it useful. If you're thinking about provisioning applications, microservices, batch jobs, then I think we can all agree that all these have very different requirements when it comes to compute. My background is in data science, so I wrote a few examples of running R and Python scripts or SQL, which can be super lightweight on your laptop or on the server where you're running that query or the R script, or it can be very complex and heavy when it comes to compute, like it might require hundreds of gigs of RAM, GPUs, hundreds of CPU cores, and so on. And finding the right resource for a job is not straightforward, especially when you are looking at the cloud options with thousands of server types at dozens of vendors. At the previous role, we were running around 4,000 containers per day, and we were looking for solutions so that we can find the right resource. And of course, there are boxed products like AWS ECS, Batch, Kubernetes that you can install and manage on your own, or you can get a managed service. But the problem with these approaches when it comes to managing data science batch jobs is that bin packing just doesn't work. Bin packing is great for applications, microservices with a pretty static load. But when you want to manage, let's say, an R script training a hierarchical model requiring hundreds of gigs of RAM with another NLP job requiring GPUs, putting those two on the same box will just not work, and you will run into over provisioning, failing jobs, and so on. So it's a mess. We came up with a solution so that we find a server for every single job, because the pricing of the cloud servers are not discounted by the size of the machine. So you can place 2 containers on 2 separate boxes compared to one very easily if you have some automations and there's no overhead when it comes to pricing. It's just much better when it comes to provision batch jobs. I included a few slides on how this looked like. It was a couple hundred lines of Python script. If you're interested in the details, super happy to share more. Now I will just focus on that it was useful not only for data science, but ETL, traditional CI/CD stuff, and many other things. We open sourced this many years ago called CloudPerf, but because this was developed at an edtech company and the development of these open source tools was decided by the business needs, it was also limited to AWS. I wanted to generalize this more, and I was super happy to see the funding opportunity from NGI Search. So we applied, and the second generation of this was born, called Spare Course, which is a collection of open source tools, documentation, database schemas, so that you can run your own tooling based on our open source repos to collect data from the vendors. If you do not want to do that, we are already running it 24/7. So we have a managed infrastructure, and we maintain databases, APIs, and provide SDKs so that we do the data collection, and you can use the data that we maintain using these open source tools. And we also provide some extra helpers so that it becomes very easy to spin up machines at any vendor that we support. You do not have to bother with how Azure versus AWS or GCP or Hetzner, UpCloud, and so on works. And we are also working on a software as a service solution. So yeah, you do not need to even engage with the vendor at all, but we can manage everything for you. High-level stats on the project. Right now we support, this is a bit outdated, sorry for that. We support 5 vendors. So the 3 main hyperscalers plus Hetzner and UpCloud from Europe, which means that we cover more than 2,000 server types from more than 300 availability zones. So just looking at the pricing of these machines, that's around 300,000 on-demand and spot prices updated every 5 minutes. And we are also looking at benchmark scores, because we start all these machines and run different benchmarks that I will share very soon. This adds up to almost 1 million scores that we maintain and make all these public and free with open source licenses, so that you do not need to benchmark these servers yourself, burning a lot of money, but you can download it from our site. The easiest way to navigate this data is going to sparecourse.com. So you can compare the servers using this Angular application. You can look into the details of the servers, and as mentioned, we are starting every single one, so you can find a lot of details thanks to the hardware inspection tools that we run on the machines, detailed pricing info in all the regions and availability zones, benchmarks like what you can see here, looking at the memory bandwidth of the machines, using different operations and block sizes, running OpenSSL block ciphers and hash functions with different block sizes, so that you can see the speed of it, compression algos, and a bunch of other things like general benchmarking tools, for example, Geekbench and Passmark. And we are in the process of finalizing an LLM inference speed benchmark using tiny to large models that I will share on the last few slides. So instead of only looking at a single machine, you can also compare those in structured tables like this one. You can generate plots on the benchmark results. We recently finished a feature so that you can embed all these tables and charts in a blog post via iframes from our SpareCourse site. So if you want to do some analysis, that's pretty easy. We also provide APIs. Here you can see the documentation of searching for servers based on different filters, so that you get a JSON response. You can integrate that in your application. We also provide some SDKs, and this is a Python looking up a server. And just to show the depth of the information we collect, here you can see that after starting the machine, we not only recorded the number of GPUs and the type, but we provide that in a structured format. And also you can look into like the actual firmware or BIOS version of the GPU, which is super important when it comes to running some specific models. A high-level overview on the components. Here you can see some URLs to our GitHub repos, the status, and the short description, and in many cases, the documentation and database schemas as well. Please take a look. Super happy to receive any feedback or raise an issue if you see something missing, and we'll be happy to iterate on that. So wanted to share a few challenges about this project in the past year. And one of the biggest ones were getting quotas so that we can run all the servers. And as you can imagine, there are many different server types. For example, at the hyperscalers, you find servers which cost multiple hundreds of dollars just to run for a single hour, and getting access to those is difficult. Fun fact that at some vendor, we opened so many tickets so that we get access to larger machines that we actually hit a quota update request quota that I found hilarious at that time. Another problem that we faced, we were often asked that at the era of LLMs, can't we just use, some large language model to parse that data for us instead of maintaining open source Python tools for ETL? And the fun fact is that you cannot, because you can see an example here, like ChatGPT searched 6 sites. It found the actual number of drives and the storage was correct, but doing the multiplication was wrong. Also, we are not only collecting data on the internet, but we are generating those in the means of benchmarks. The biggest problem after these two fun facts was actually the availability of the data. So not data quality, but even the availability. And to show you a quick overview of how to get just the pricing of some machines at some vendors, it's not like you do an API query and you get back the price of the servers, but you have to do a bunch of lookups in unstructured data, like figuring out the instance family of a server, then based on that, multiply the pricing of a CPU based on the instance family with the number of CPUs at some premium pricing. So it's quite a mess, honestly. The great news is that SpareCourse delivers this data in a structured way. You can go our site, take a look at the web application and collect the data manually there, or you can download the SQLite database and do the queries yourself writing SQL, or use our APIs, SDKs to get access to the data in a programmatic ways. And I know we have only 10 minutes, so we'll just spend 20 seconds on the recent updates. I was super happy that we were featured by the Programmatic Engineers, the Pulse newsletter in October, which received over 2,600 likes and reshares. So we got some very good feedback from the community. We were a top post on the AWS subreddit for some of our articles. We try to present on our solution at multiple conferences, integrated new vendors. There were some pretty exciting web updates that you can see here, including new benchmarks like Passmark in October. And what we are currently working on is benchmarking for LLM inference speed using prompt processing and generating text as well, with super tiny inputs like 16 tokens to pretty large ones like 32,000 tokens, and using small to large models like the 70 billion parameter Llama 3.3 requires multiple GPUs, but publishing this will let you go to our site and select a model, say the number of tokens you want to process, and you will be able to sort all the servers from the 5 vendors per price per token or whatever metric you require. So I think that's pretty exciting. Regarding the team, I'm in a good company, as you can see from the profile pictures. Attila is working on infra, Balu on the front end, and I'm trying to do all kind of things, or none of these, depends on your perspective. Super grateful for NGI Search for the support so that we could work on this, and I'm pretty sure that it will be useful for many folks in the coming years, and we plan to maintain it. So Mirko, thanks a lot for sharing all the related possibilities, like how to maintain the project after funding is over. And yeah, I know time is up, so I will stop here and stop sharing screen, but please check out sparecourse.com. If you're doing anything in the cloud, then I'm sure it will be useful for you. So thank you, everyone.
Awesome. Thanks. That was really good.
So I will speak about social issues, which is part of OpenFoodFacts. It's a project funded by NGI, and we are very grateful for that. Here is what I will present. And so first about OpenFoodFacts, if you don't know it, so you know that what we eat matters a lot. There is a lot of overweight, and it is causing a lot of problem with health. And also there is the problem of greenhouse gas emissions linked to food or food industry, water consumptions also, and packaging waste. So those are all well-known problems, I think. And OpenFoodFacts is trying to empower consumers, producer, researcher, government to measure and change the impact of food on our health and for the planet. So you can see here the mobile app, which helps you choose products that are good for your health, good for the planet, and that's not Nutella. So we had a systemic role in Nutri-Score creation. I hope you know about Nutri-Score. So it's something that really helps people. There are numerous studies showing that it really helps people choose more healthy food. We did have an initiative which is called, which is called Green Score now. It's not called Eco Score anymore, sorry for that. And we have a lot of products in our database, more than 3 million actually. We have a lot of users visiting our website, using our mobile application. And we have also a lot of reusers, a lot of applications reusing our data. That's the way it can be done with open data. And why searching is important in this context? So every day you make choices about your alimentation. And we want you to have choice about what you eat. And we want to make the products that are in our database reachable. And you may have different criteria for what you search: a healthy diet, low environmental impact, allergies, ingredients, etc. So there are a lot of things, like also ethical considerations or religious concerns and so on. So that's why search is important. And today it's a challenge because most of the people that land on OpenFoodFacts website land there because they have done a search using an external search engine, which is owned by companies. And you know, our icon, our logo is half a search icon. So it's a bit of a pity for us because our current search is not, it's not is not good enough for people who visit our website. We want it to be as good as e-commerce. We want it to be discoverable and simple. We want also to make complex queries possible because we have a lot of advanced users who use complex queries to really mine the database. So it should be also, we have a personalized score on products. We want it to be transparent. We want it to be privacy first because it's your choices about alimentation are yours and shan't be public. Okay, so today we have it, but it's not on the full database. So we want to make it on the full database. So it's currently about to be done. And also we have a lot of other advanced scenarios around search. For example, we want researchers. For example, yesterday, some researchers asked us, how do I find all the whole meal breads? Maybe some are well categorized, maybe some are not. So I want to reach all the whole meal breads because they are doing a study on ultra transformation of products. We have a lot of researchers using the database, but there are also reusers who might benefit from it and contributors. So the Search Alicious project. So it's a project to have, here you see our target UX. It's not, it's almost done, but not yet completely. So what we have deployed in production already a beta, which is far more relevant and fast. It has a powerful API. It supports for many languages. And on that, we had done a recent rework so that it's even faster and even comprehensive of using more synonym and that kind of things. And also, it's not a search engine only for OpenFoodFacts, but it's really a reusable project that can be used by many innovators on other projects. So it's really based upon existing open source bricks like like Docker, like Elasticsearch, or OpenSearch, like Redis-7 it uses web components so that you can reuse. Even the interface is easy to build for your project. And really, it tries to have only one configuration file where you really define what you do. And then you can start the project and you can build your HTML pages using components, web components. It's Open API compatible and it's built upon the Lucene query language, but with a parser that enables a lot of transformation and smart behavior according to the queries. And it's supporting taxonomies, which are very important to OpenFoodFacts. That is, it's able to use synonyms and translation in a lot of languages. And yeah, it's something we will deploy also for Open Beauty Fact, Open Pet Food Facts, and Open Products Facts, which is our side projects, but which we are currently trying to grow. So yeah, I would like you to know that really it's a reusable brick. So really it's I think we did a hackathon lastly this year, and there was this data about food product recall from the government. In 2 days of the hackathon, we were able to make a search engine with this data, and we won the hackathon thanks to that. I want to show it to you. Yeah. There we are. We were the team which won the hackathon with that. And really, it was about reusing open search issues. It was, we had just to transform a bit the data to make, to tweak a bit the importer of the data, but it's, some mechanisms are provided by search issues for that. And we were able to have something really that was, that makes people, crazy that it was so easy to do that. And yeah, so and also about that, about reusage, we have made some progress. We have made lately it's to have really an extensive documentation for users, for reusers of this project. There is a tutorial, there are in-depth explanations, reference on different things like web components and so on. So really, it's very interesting, and we are really trying to have reusers of this framework. You can see here the GitHub project. It's OpenFoodFacts search issues, and yeah, lately we didn't have the time to really make progress, but we will in the coming months really make progress. We really need, it's not yet deployed largely in production for every users, but we are really looking into it, so it will come soon. It's very important to our project. That's it. Thank you so much.
Yeah, hi everybody. My name is Holger, Holger Kienle. I'm based in Berlin, Germany, and my talk will be mostly about Open Source Ecology Germany, which is an NGO. We abbreviate it also with OSEC because, yeah, just to keep it a bit short and sweet. And Open Source Ecology Germany is also, let's say, related to open source ecology in the US. I mean, we're loosely related. I only mentioned that because OSE with Marcin Jakubowski might be familiar to you because he had a viral TED talk at some point, and also kind of pushed, let's say, open source hardware and the idea of local production and so on. He pushed that kind of in the limelight. So again, we're related to that idea and have loose ties, basically, with Marcin. That's so much for the background. And what I want to do is I want to introduce or have a few highlights of what our NGO is doing with the hope of maybe identifying touch points or get you interested in OSEC and hopefully potential collaboration. Because our NGO is, I would say, relatively diverse. In a sense, there's certainly there are a lot of computer scientists involved, and I myself, I'm a computer scientist, and there are also people in mechanical engineering and so on. But we have also people who are more interested in, let's say, the community building side of things, who just see the value of open source hardware to bring that to, let's say, to society. And we have also biologists, for example, and so on. So we're fairly diverse. Let me also point out that we also, or one important part of open source hardware is also circular economy that really ties in nicely to each other. In a sense, one helps the other. So that's also an important concept. And let me point out that we are about 50 members, so it's a relatively small NGO. But as I said, we're relatively diverse and pretty much based in Germany. And even so, we're based in Berlin. It's more, let's say, a virtual organization. So our members are primarily all over Germany. So again, you shouldn't think of us too much as Berlin-based, I would say. Yeah, as I mentioned, we're also into networking and hoping to get registered into perhaps working with us. And now let me just briefly go through some projects that we did in the past. One project is dealing with introducing a standard in terms of documentation for open source hardware, and we were working with DIN, which is kind of the German standards body, and that was actually interesting in a sense. First of all, we had to get DIN, let's say, interested into the topic of open source hardware and to argue why a standard in that area might make sense. And then we also had some, had to, let's say, convince DIN that, well, if we do an open source hardware standard, then, well, we need also an open license. So that's something that they hadn't been done before. As you might know, the DIN or standards bodies are fairly traditional in their thinking. And getting or introducing to them the idea of having an open license, for example, and even having a download for free with this DIN spec, was not an easy feat to accomplish. And the DIN spec itself that basically talks about how to do, let's say, proper documentation for open source hardware. And the idea here is to basically look at both sides. Well, if you let's say developed or finished an open source hardware project, you might wonder yourself, have I done a good job with the documentation? That's the one side. And the other side, if someone wants to use your open source hardware project, they may also like to have some assurance that documentation is up to a certain standard. You don't want to invest a lot of time and effort, let's say, to understand an open source hardware project, to then find down the road, oh bummer, there are certain aspects that are not open, and basically things that hamper actually open development. So that's why that standard makes sense for both sides, and also for industry, because they look to standards like, or to organizations like DIN, for example. They just have a better feeling, let's say, if they know, oh, there's a standard and DIN is involved. They already know DIN, and so this is basically helps to push this topic into industry. So that's one example. Let me move on to another one that is closer to NGI Search. This is a repository of open source hardware projects. And this is, on the one hand side, it's a search engine. On the other hand, it's also curated. So certain open source hardware projects are, the platform works with these open source hardware projects to get the documentation to a certain standard. And particularly one larger project that we have been involved is with a hemp harvester. So let me search for hemp, and you see actually three projects, but the one I'm after is this vertical drum harvester. So that also shows it's some serious project with lots of parts. So this is actually, I hope you can see that, it's actually these drums that I'm talking about, not the tractor itself. So the drums are basically attached to the tractor, and in this project, actually, that was about reverse engineering. So one member of OSEC, he was basically reverse engineering these drums, and and actually quite a bunch of parts, and to create cat with those. And oh, just a sec, sorry for that. Very sorry for that. Our dog was acting up a bit. And yeah, quite a bunch of parts, as you can see, and a fairly involved project to document all that. Okay, let me move on. I don't have too much time, as I just realized. Another project that deals more with community building and communication is our Open Eco Labs. Well, first of all, Open Eco Labs, we had within our NGO, we started out by defining what we mean by that. And it's a loosely definition. We don't want to be too exclusive, but it's basically about, let's say, spaces that are built around a local community, that are basically a hub, where people can learn about things like sustainability, and can build and repair, and do perhaps local agriculture, things like that. And this particular project was about also identifying candidates for Open Eco Labs and then documenting them in a map. And that was basically the result. It's currently German-based, but we want to expand that. But it's about identifying basically, let's say, candidates that fulfill the criteria of an Open Eco Lab, and so give people a starting point to connect with them. And often these Open Eco Labs, in a sense, they don't know about each other as well. So the last thing I want to talk about very briefly is one project where we, first of all, there's a VHelio project. It's based in France, I believe, about this e-bike. And what we did is we replicated this e-bike, and within our NGO, so we purchased the parts, and one member or several members, they built the e-bike, and then we also made sure that the documentation confirms to the DIN spec that I talked about before. So again, by recreating or rebuilding it, and working with the original creators, we basically verified that the plans are up to the DIN spec standard. So that was also a nice result. Okay, that brings me already to the end, or I think I went a bit over my 10 minutes. Sorry for that, and yeah, happy to take questions.